Sure, my name is Mike Duffy, and I'm in Applications Engineering here at National Instruments. So the idea is it uses the compact vision system as well as compact Rio. It takes images here from the camera and then interfaces with the motors to actually go through and solve a Rubik's Cube. We take images of a scrambled Rubik's Cube, and from there we then pass the array of all the information about the faces into a DLL that we have. Actually just a DLL that came from online. We didn't build the algorithm itself. It was pre-written already. But essentially, we're calling into that algorithm here on the compact vision system right after we take all of the photos of the faces. Then what we do is we're communicating over Ethernet from the CVS over here to the compact Rio, and what we're doing is basically just transferring all the information that we need about the steps to go through and solve the cube. Then at that point, once the compact Rio has all of those steps inside there, then it interfaces with the hardware to actually implement each of those steps and to go through turning the cube in ways that it can then rotate the faces appropriately. Sure, right. So then also what we have is, we have two applications, one that's running on the CVS, one that's running on the compact Rio itself. We also have another host application that's running here on the machine, and what it's doing is it's receiving information back from the compact Rio concerning the current state of the Rubik's Cube itself, and it's showing up here onto the 3D picture control so we can kind of follow along with what's going on. So unfortunately what's happening at this point is the motors, they had replaced the motors after a couple of the other motors had burned out, and they have some different characteristics than what the demo was originally built for. So what happens is now the Rubik's Cube goes through, and as it's trying to make the turns and make the solutions, it will turn but it won't complete a revolution, and then so when it tries to turn another way, it's going to get a little bit locked up. So then it kind of gets into a rough state, just based on that difficulty. But what we can do is if we remove the cube, as long as the gears aren't going to obstruct each other, then we can watch the algorithm finish off basically on the three-dimensional cube here on the display. So you can almost follow it yourself if you had it in the right configuration. The screen image actually came from the photographs of each of the different faces of the cube, so it would be the steps that it would be proceeding through. Now, one thing that I did notice is when it was photographing the cube, at one point it might not have lifted the hand high enough, and so if it did that, then it would interpret one more of the squares to be a white square than the color that it actually is based on the color that we have here for the gripping hands. So if that would be the case, then it might be confused and it would just be stepping through an algorithm that would never finish to actually give a solution. But I think right now it might have stopped, so right now it might have noticed that it has, it might have photographed one of the faces wrong. It might realize that, it's not solvable at this point. It's great to see it working, and, we're going to be working on some of the kinks so that next NIWeek it'll be fully functional like you can see here in the video.
Okay, thanks a lot.
My pleasure.